Assalamualaikum warahmatullahi wabarakatuh, everybody. Welcome to another video of CS Point, and this is of the course 221 algorithms. Today we are going to solve a complex problem. In the last video of codes, I showed some types of sorting to you, and before that there was a video of explaining sorting, and in the last video I showed how you do the same thing in codes. So you might know what graph is. I didn't have a video on graph yet, but I did have a video on BFS and DFS, but I'll still try to make this a quick video. But we'll go through graph, and then we'll have to go through this problem. It can take two, but let's begin, inshallah. So first thing is about graphs. We all know about graphs, and we know about BFS and DFS. So let's start drawing. 1, 2, 3, 4, 5, and you have 6, and then you have 7. So if you do BFS, breadth first, then they will, if from 1 you will first check this layer, and then this layer, and then this layer. So it will be kind of like 1, 2, 3, 4, 7, 5, 6. Okay, but if you do DFS, depth first, then it will be 1, 2, 4, 7, 3, 5, 6. Okay, 1, 2, 4, 7, 3, 5, 6. Now, okay, let me write it. 1, 2, 4, 7, 3, 5, 6. Okay, that was a revision of BFS and DFS. Anyways, now let's get to this problem. We have been told to create a maze.txt file to represent the input of the maze below, which probably makes no sense for now. Each tile in the maze represents a node and is labeled with a number. If you can go from one tile to another, move left, up, down, right, whatever it is, then there is an edge between the nodes. That means if you are able to go here, then there is a notch. If you go there, there is an edge, 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 and so on. Apply DFS algorithm to solve the maze below. You have to start at node 1 and end at node 9. Once you have reached your destination, you should terminate the algorithm. Thus, slight modification to algorithm in task 1 is required. Blah 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 blah. So basically the thing is, you have to convert this into a graph. No, you have to do DFS over here. Now when you're told that you have to do DFS over here, that means you need at list or a graph. Without that, how will you do the DFS, and what will you do your DFS on? Like, you can say that, okay, use the ketchup to eat the fries, but if you have a ketchup and you're not given anything, you're like, I need something to eat this ketchup with. And fries, what fries? Like fried chicken, or what? It's just like that. Okay, this is a requirement. So let's take a good color and start making the graph. Okay, now how will I make this graph? Because this doesn't look like a graph. Like, there's this 1 over on the top, and then there's this 3 in the below, and what's this 4 even doing here? I don't even know. How do I deal with this? Okay, at least you know that 1 is the start. So let's just start with 1. Oh, I can see that. Okay, change the color. White it is, but then I can see it over here. Oh man, yellow it is. 1. Okay, good. Then you have 2, so you can easily put 2 over here. But can you go to anywhere else with 1? You cannot go here. Nothing here, nothing here, nothing here. Only 2. Okay, then that means 1 is connected with 2. That part is done. Now 2, you can go to 5, you can also go to 3. So let's do that. 2 with 2 we can go to 3, and we can go to 5. From 3 we can go to 4. So okay, from 3 we can go to 4. From 5 we can go to 6. From 5 we can go to 6. From 6 we can go to 10 and 7. From 6 we can go to 10 and 7. I'm running out of space. From 7 I can go to 8. And from 8 I can go to 9. Okay, just imagine there's 9 there. And then you have 6 to 10, and from 10 I can go to 11. So this is my graph. Now, there are two ways we can do this. I had a way. I put 3 on the left side, and this thing over here, it is for 2 in the 3 in the right side. Okay, so they went through this first, and then they went through this. Anyways, it's up to you. It's no problem. It doesn't matter. You will, as long as your DFS is working fine, it doesn't matter. So if you do this, then you will have 1 2 3 4 5 6 10 11 and then 7 8 9. Now guys, some of you are confused that why is 10 and 11 and say 10 and 6 repeated. This is an error. Ignore that. You can ignore this part. Okay, this part you can ignore it. Okay, now we are starting from 1. Now let's use another color. So 1 2 5 6, you pick the left first, so 10 11. So far it's identical, right? 5 6 10 11. And then you have, okay, nothing here, nothing here, nothing. Oh yes, there's something here. So 7 8 9, 7 8 9. It's completely okay. And they didn't show 3 4. It will be 3 and 4. Or for this graph that I drew, it will be, let me show you if you're confused. For my graph, it will, the DFS will be 1 2 3 4. Isn't that nice? And then 5 6 10 11 7 8 9. That's why they told you that this is one possible solution. For example, one possible solution is this, and this is another solution that I came up with. It's okay, don't worry. I have asked the teacher and they said that this was an error. This is one BRAC problem, by the way. It's a lab 3 problem. Anyways, and then you will have to use BFS to solve the same maze. So it will be 1 2 3 5 4 6 10 7, something like that. You see? Now what are our tasks? First, I have to make this graph in the code, right? I'll have to make, this is a graph I draw with my pencil easily. I can make another one, but I need to get this on code, and then I need to apply DFS, and then I need to apply BFS, and then I need to compare the time needed for the two solutions and print which one is better. That's a lot of work, by the way. So we're going to skip this part. We're not going to do this, but we will do up to this. That's my intention today. We're going to do up to this. So let's get straight to the point. Okay, these are my codes, and I have a package. As you know, NetBeans works with packages. I'll show you one thing over here. And as you can see, there's this package CS point. You have to create a package. I showed you in the last video. You have to create new project and then a Java project. They will automatically ask you for the project name. You give a name on your own. You create a main class with your own, with the name you want, and then the rest. So that's how I created this. So anyways, what did I do over here? First thing is, remember, I need to create the graph like this. So to create a graph, I need to create an adjacency list, or I can also create the graph directly, but I will show you the adjacency list too. Okay, so we were told to take the input from a file, right? So these are a bunch of inputs I need to do, but you don't have to worry about that now. I'll tell you step by step. First I create the maze, and the maze class maze, you can name it whatever you want. I take an int v, which will be the size, and then I create a linked list of integer. You know linked list, right? And then this is the constructor with the v. The new linked list will be created, and for each linked list there will be another linked list. Okay, and there is obviously the part of the edge, which is a method that is used to add something to the linked list. So your graph is in form of a linked list, and along with that each linked list node has another list. So this is how you create the graph. It's pretty easy, and I have like written out the commented out the sections, and you can check them, and you will find this. It's easy from Geeks and Geeks for Geeks. That's the website. You can take their code. I did it the same way, but I don't have the energy to write it again, so you can just use this. It's pretty easy. And iterator is iterator, like it iterates from 1 to 1. If you know what iterator is, it is from 0 to 1 to 3 to 4. So that's why we use iterators. It's a thing in Java, it's a class, and we use the list iterator to iterate through each node. Okay, and we used boolean to check if they were visited or not. And this is the DFS method. Now DFS, and this is the BFS method. Okay, but you may wonder, is DFS that small? No. This part, as you can see, this part over here, this part. Okay. And for BFS we have this part, same thing, with a linked list in a linked list again, which is of integers, and then you will use the Q to do this, and then we'll check it. The difference that is made is over here. Maybe I'm going too fast. Okay, then I'll show you. These are the two parts that makes the difference, this part and this part. Let's start with DFS. Okay, so as the comments, you have a int and you have the visited, which is very necessary, but some people do it with the int, you know with 1. So if it's visited, they put it 1, and if it's not visited, they put 0. You can do it in your way, but boolean is very easy to do. So we will mark the current node as visited and print it. So this is for printing out the current node. Okay, and then we will use iterator. This is DFS. Okay, we will use the iterator and use the adjacent v. V is for the vertex. Okay, we're going to the vertex. As you can see, it's also written over here, probably recur for, yes, it's written over here, recur for all the vertices adjacent to this vertex, and you use the iterator to go through the v, all of the v of the iterator list, and then while it has next, that means something exists, int n will communicate that and whatever it has, and then if it's not visited, then you will do DFS iterate with for that edge again. Now you may recognize this, that this is this function. Okay, so as long as there is an edge, this will occur recursively. This is recursor, and visited will keep sending visited again and again, because for that node it has to be true. And once we reach a part that every part is visited, then this recursion will stop. That's the base case. This is the base case. Okay, and when that happens, then it's now. How did I get into this? We did this using this. We created the boolean visited for v vertex, because obviously we will do it v times. It will never be more than v, because we have v vertices. And DFS util will run until, it will keep running itself recursively until all are visited. So that's DFS for you, and you will get that result. And for BFS, it's almost the same thing, except we need to change our strategy. We use the iterator to go through the vertices in depth, but now we'll have to check all the edges on the vertices, so we need a queue. So here we have this linked list. Here it was just a normal boolean array, which was easy to do all the work, and we just required an iterator. But here I have to create my own queue. Okay, because it's not normal, because vertices to vertices I'll have to check all the edges. Like each edge I have to go through all the vertices, so I need my own queue, and of course I have that same old boolean array, and I will keep adding if it is true. So q dot add s which is true. And how am I judging this? How am I reaching this? Look at over here. If q size reaches 0, so q dot poll, that's kind of like dq, you can say. So sq poll, and it will happen and it will print the value in it. Now if you keep polling, there will be a time, it will be like dq, sorry, there will be a time then you will have nothing to dq on. So when all the vertices are reached and you're done printing them out, now you can do the same thing for the iterator, and until there is a next, that means it exists, you apply recursive. No, we don't need recursion over here. Yes, we don't need recursion over here. Visited, and you keep adding the edges. Keep adding the edges until you have all. Okay, all are commented out. If you forget it, it's okay. All are commented out over here. For example, you will have to get all the adjacent vertices of the dequeued vertices. That's what we did over here. We dequeued the vertices to get them. If adjacent has not been visited, then mark it. Then that's what we did above over here. And then visited and enqueue it. That's what we did at the end. So that's how it works. BFS is kind of complicated, but DFS is very easy, as you can see, only 2 functions. But both of them requires an iterator, and how you go through them is exactly the same, except you have to apply a recursive function of that, since you are going to the depth. But for BFS you can just add another edge, n, which is the dot next, you know. That means if you are on I will draw this for you. If you are on here, so I have to go to next instead of going down. If I want to go down, I will have to use the other vertex, and that's why I do DFS of it, right? 8, whatever. I think you get the point how the codes differs. Almost same, guys, almost same, but you know where to change. The change is on one of the, I'll show you the major change part. First is, how are you, on which basis are you judging that if it's not visited, what kind of action are you taking? How are you judging your path? For DFS, you're going in depth. That's why you're recursively starting the function for that vertex again. But for BFS, you don't have to do that, because you need to go through all the edges. So you can just start to the next, go to the next edge, dot next. Okay, I think you kind of get. Using the same thing, we are applying the recursive function for DFS and applying you can say, not function, applying, adding or tracing through for BFS. I'm out of terms today, that's why I'm kind of like not sounding so cool. Anyways, you get the code, I guess. Okay, that was for BFS and DFS. Now how do I take input of a file? Now for this, I will now explain. We need a linked list, because that's how we created the graph. We need to also include the iterator, because you know I have to iterate through the list. Now I can take all of this. If I just write util.start, then it will import every single thing from the util class. But I purposely didn't do that, because I want to show you exactly what are the things that you need. And you need a buffer reader. I'll show you that now, and these things I'll show you now. Okay, now we have to take input from a file, right? Not this. Okay, so for file you have to first include the exceptions, which is throw, file not found exception, and IO exception. Okay, which is for operating system. Anyways, buffered reader is a file reader. For example, I'll show you the file. Here we have the file maze. Okay, this is the file. On which basis did I create this? You can tell 1 2 2 5. Okay, I'll draw this for you. See, 1 2. Okay, so from 1 you can go to 2. What's next? 2 5. Okay, 2 to 5. 2 to 3. Okay. 3 to 4. Okay. 5 to 6. Okay. 6 to 10. Okay. 6 to 7. Fine. 10 to 11. Sure. 7 to 8. Okay, as you wish. 7 to 9. So this was the exact same graph that we drew, except we had 3 and 4, this part, on the left. That's the only difference. It doesn't matter though, you can also do that. Okay, so now we'll apply BFS and DFS, and in case you're wondering what's 12, I'll show you later. So this is the size of my, that means I'll have a 12 for 12 graph, you know, multi-dimensional array. 12 for 12, if that explains better. Or for 12 list, each 12 will have 12 lists. So 12 from here to here, and also 12 from here to here. Okay, that explains. Now this is located on local disk E in my hard disk. Here, maze.txt. So I need to import this file. That's why I will write, okay, buffer file. You go to E, and notice that we have 2 slashes. Go to E, and even if you had a folder, you will still use 2 slashes. Okay, it's not like the navigation on my computer or run. You'll always have to use 2 slashes. Go and get maze.txt. Buffer reader is used to read that file, and new file reader is itself a reader which will read that stuff from the file, and buffer reader will read it line by line. How it will do it? And before that, before I do everything, I'll have to create the maze class. What is the maze class? This is the main class. That means this class. Okay, so all the stuff for the graph has been created with the maze class. String A1 BR1, which is this one, it's told to read line. Read line will read this line. So first line is 12. Okay, this is the line, one line, and we only have 12 over here. Do not include spaces, because Java will recognize this part as an empty string. Do not do that. You have to make sure that there are nothing left. So if you keep pressing the right array or the left array, your files don't go like this. If your array is taking if your arrow is taking you to a space, then you have to backspace it out, otherwise your program will not work. This is not a drill. Okay, so now you have this buffer reader who is reading the first line, and he got a string of 12. So 12 is not an integer here, 12 is a string, but I cannot work with a string, so I have to make it into an integer. So I use the method parseInt to take the string and make it into an integer, and I create a graph which is multi-dimensional with 12 and 12. Isn't that easy? And then I keep reading the lines until it reaches null. So if you have a space over here, for example this, that means you have an empty line, and I cannot have that. That's why I will remove this. Okay, save. Now go on, keep going ahead, integer person. Now when I get a string, for example this is the second line, 1 and 2, this comma is a problem, and I need these two separately, and every string is an integer of chars. So we have 3 chars. The array of this string has 3 chars, 1, a comma, and a 2, these 3 chars. So I need to split them on basis of the comma. That means this one. So there is index 0 and index 1 when I split them. After there it was index 0, 1, 2, but when I split 1 out of it, now this is 1 and this is 0, and put the value of index 0 on int x, that means 1, and put the value of index 1, 2 in y. So in x now I have 1, and in y I have 2. And now go to 1 of 2 and 2 of 1. That means if this is the graph and I have 1, 2 and 1, 2, 1, 2, I will put 1 over here, and 2, 1, that means I'll put 1 over here. 0, 0. 0 is by default. this is the thing I did over here. I'll show you with a clear drawing. 1 2 1 2, go to x is 1 and y is 2, go to 1 and 2, so 1 2 over here, star. I'm actually putting 1, so we're putting 1, and 2 1, that means over here. From 1 you can go to 2, and from 2 you can go to 1. You can go to 1 1, or you can go to 2 2. That doesn't matter now. This is what we did, and we did the same thing for our graph. So we added a edge 1 in a linked list 1. We added another list which is 2. So we added an edge. Okay, this is the graph. So we are creating an adjacency list and a graph both at the same time. We are creating the adjacency list using a multidimensional array, and we are creating the graph using a linked list, multiple linked list actually. And once I create the graph, I will have to print DFS method, BFS method for the first index, I mean for the vertex 1, and then I will print my values. Now what I have to do is I have to run it and check if I'm doing well. Okay, by the way, this is how you print the multidimensional list. This is for printing out the list, and this is for printing out the DFS and BFS. Now we have to run this. Okay, it's running. Could not load main class because I didn't load it. Okay, fine. Okay, here we have it. DFS, guys, 1 2 5 6 10 11 7 8 9 3 4, exactly as the problem wanted, excluding the 3 4, and I told you that 10 and 6 is an error. You don't have the same values in any DFS or BFS, so it's exactly the same as this. And BFS would be 1 2 5 3 6 4. You go to all the edges. DFS is working fine, BFS is working fine, and this is the adjacency list of the text file, this one. If you draw the list of this is what you get. So that was a lot of work, and you also can do the same adjacency list with array list. I have a code of that too, thanks to a friend of mine, as I didn't want to spend. You will find all of these codes, guys. What matters is you have to understand how it works. I hope I was able to explain, and you have commented sections, and I think you can use this maze file. I will upload all these files in the folder. These are my files, so you can use it for absolutely for free. I mean, you don't have to worry about somebody's codes. No, you can use them and practice with them. Make some modifications in your graph, change the text file, and check your code. I hope it was helpful, because many of you face problems with this graph problem, and especially in the problem that had this lab. So hoping to see good graph programs from you, because you will be doing graphs all over 2-to-1 algorithm, and will be coming with minimum spanning trees tonight, inshallah. Until then, happy surviving.